In comparison, if you have open or dynamic system, you should use trust not instinctively and implicitly, but in open or dynamic system, you should use it consciously, not gut feeling, consciously and explicitly. Suppose that you move to a big city, okay, or just a town, okay, that is open, dynamic, like a university town. Maybe it's not big, but very dynamic. People are moving, coming in and out. And anyway, it's too large to know everybody. So if you look, for example, for a good dentist in a new town, you would ask your friends. Okay? Explicitly, you are trying to find who they trust. And if you trust your friends, you'll use a recommendation. Right? So now you treat trust, you have some conscious and explicit reference to trust. You might not use the word trust, but you say, hey, who is a good dentist? How do we establish trust? By interactions. You build trust by interacting with others, people, organizations, things, artifacts. And interactions, of course, there are different interactions. Could be simple transaction, complex collaboration. There are issues like how to establish initial trust. You don't know somebody at all. Person walks into classroom. Well, if I know it's a student from Purdue, I already have pretty high trust for that person. Much higher than for a person from a street, okay? Because it is, being a Purdue student carries with it a certain, positive qualities. That this is an example of trust of an organization rubbing off on members of that organization. There are many approaches known in the literature for trust acquisition. Here are just 3 examples listed by observation, interaction, using institution. I just give you example of a trust into institution or its reputation rubbing off on you. We can look at different elements of trust, how trust, reputation are related, and what is the value of reciprocity in building up trust, and how such relationships can be reinforced. These are all interesting subjects. Suppose now that in a computing system, I want to know what value of trust I can give to a certain service which I intend to use. I might have my own experience, first-hand experience with that service. I use that information. I might have reputation information from others, second-hand experience. I have to somehow put together that information. And that second-hand experience could be from like BBB database or Better Business Bureau database or some other consumer information places. I put them together, and I have to calculate a single trust value. Let's say to make things simple. Let's call it it might be a vector, but let's say a simple value of trust level that, in my eyes, that service earns this trust rating. And here are different ways how you can calculate that overall trust. A few examples of different approaches. The typical approach to trust nowadays, and we'll be talking about that in a moment, is that people typically don't look at the comprehensive, broad foundation of trust throughout the whole system. They basically build piecemeal trust management mechanisms for individual security services or mechanisms. We're talking here about security services, not all services, but you could probably say the same thing about many non-security services. So you have, for this mechanism, such trust values, trust such and such. The issue is now, if you try to build a federation, let's say, or build another system on top of those individual systems, subsystems, this issue of interoperability of trust. Trust degradation recovery. Well, if somebody trusts you and you disappoint her, you lose trust very quickly, right? Somebody trusted you that you will not cheat, you cheat. Oh my, terrible transgression. it will take a long time to gain again the same degree of trust. So, fast degradation, so that's what we had on the previous slide, fast degradation and slow recovery of trust. So, if trust is so pervasive in society, why not to use it? Pervasive trust as a paradigm of computing. Now, again, I'll talk a little bit more about that, but some people see trust as component of security. I see trust as an overall foundation of security. Okay? Not trust in the small, and I'll use the term in a moment, but trust in the large. So trust is already used in computing systems, but mostly, as I say, in a piecemeal fashion. What the claim that I'm making is that trust should be even more pervasive in computing systems. So, some of the challenges of extending the trust basis might include defining trust for also artificial entities, for more artificial entities, and also to make explicit what are subconscious uses of trust by human users or by non-human users. Dimension of trust are competence and intention. Sure, you trust your mom. She has the best intention. But she's not the airplane pilot. Would you fly with her? Would you trust to fly with her? No. Neither would she trust you to fly with you unless you are a pilot. So, competence and intention are two levels of trust. Second thing, trust is not a binary. It's not like I trust somebody or distrust. There are different degrees. Binary is just a simplification, which might be good in some situations. Good enough. You have to trust somebody. You can't trust everybody, but you have to trust somebody. If you don't trust anybody, that's the situation I already mentioned of a complete paranoia of a miserable life or a completely inefficient system. Trust is asymmetric. I can trust you more than you trust me. Trust is also, well, we already kind of goes with that. If it is asymmetric, well, we're talking about also bidirectional. Who should you trust? Anything can be trusted. Trust, what is the relationship of trustworthiness and trust? Trustworthiness is a very often mentioned thing. Trustworthiness, if something is trustworthy, it implies it's usable. If it's usable, you use it more often, you build up trust. So we might consider in much more detail those relationships, but enough just to mention it now. If you try to use trust, all its aspects for every, let's say, security mechanism or security service, you will basically create a system that's terribly inefficient. Trust includes so many different factors, criteria, viewpoint, that you have to basically, whenever you design something, select what is appropriate for what you're doing. You should avoid and also when you build up trust, you should avoid demands for too much evidence. So, you don't trust people unless they give you more and more evidence, or you avoid asking them, they give you too little evidence, then they don't trust the system because the system appears to be lax. So, many other research issues that are summarized briefly on this slide. It's not to study, so just to show how many different, basically in each column you have one or two subtopics with references, so you can see, for example, even three subtopics here, so you can see how many different issues are very diligently studied. Let's take a look now at Pervasive Trust Foundation for the future Internet, or at least for its privacy security portion. We know about, the roughly from an NSF summit, people were saying, okay, we are in the second Internet 2.0. Internet, future Internet could be called Internet 3.0. I, try to compare the design or Internet 1.0 with Internet 3.0. the original internet were designed